C3, transforming graphs of functions, example 14. Sketch the graph of y equals 3 mod x minus 1, take 2. Well, I'm going to start with the graph of y equals mod x, so I know what that one looks like, and then transform it 3 different ways. First of all, it's going to become y equals 3 mod x, and then I'm going to make it become 3 mod x minus 1, and finally 3 mod x minus 1, take 2. So before we draw this, just think about what you're expecting to see from each transformation. So we're beginning with the y equals mod x graph. There it is. Y equals 1 times the modulus of x. When we write this, we don't normally bother writing the 1. So let's take a look at what happens here as we transform. First of all, I'm going to turn this into 3 mod x. Think about what you expect to see. You should expect to see a stretch in the y direction, scale factor 3. So a point such as this one, 1, 1, should end up at 1, 3. Likewise, the other side, minus 1, 1, should end up at minus 1, 3. So here we go. And that is what happens. We now have 3 mod x for our graph. Next, inside the modulus signs, we're going to have x take 1 instead of just x. So x minus 1, I'm going to expect to see a translation 1 unit to the right, and that is exactly what we see. And then finally, a big minus 2 at the end. Because it's not inside the brackets or the modulus sign, I'm expecting to see a translation down by 2 units, and that is exactly what happens. So when I sketch this graph, think about where it's going to now cross the y-axis. Just quickly return to the original graph. The original graph only went through the axis of the origin, then it was stretched, still just the origin. Move 1 to the right, now goes through 1, 0 and 0, 3. Then we move it down by 2. It'll go through 0, 1. And we'd have to work out where it crosses the x-axis, but it would be a third at this point and 5/3 at that point. You can find that by making y equals 0 in the equation and solving.